Welcome to Lesson 9-4, Performing Rotations. In the past, we have rotated figures around the origin. In this lesson, we're going to learn how to rotate figures about a point other than the origin. Use a protractor to draw an angle measure of 20 degrees. So you're just practicing using a protractor. Given the points A of 3, 5, B of -5, 3, and the origin, we're going to call that O, which is at 0, 0, obviously. Find the length of segment OA, OB, and the measure of angle BOA. So you're going to use distance formula. 3 minus 0 is 3 squared, which is 9. 5 minus 0 squared is 25. 9 plus 25 is 34. The factors of 34 would be 2 and 17. Those are both prime. So the length is 34 in simplest radical form. For B, -5 squared is 25. And 3 squared is 9. Because 3 minus 0 would be 3. So both sides are going to have the same length of 34 degrees. Now you notice here that the X and Y digits are flipping. So it's some kind of rotation that we've learned before. The 30, 60, 90, how we're moving from one point to the next. So we have 3, 5. So 3, 5 is going to be here. -5, 3. Going to be there. This is going to be 90 degrees. You could check that by checking the slope on each of these, but it is a 90-degree angle. Recall that a rotation is a transformation in which a figure is turned about a fixed point, called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. A rotation about point P through an angle x degrees, we haven't told you what that is, maps every point Q in the plane to a point Q prime so that one of the following properties is true. If Q is not the center of rotation, okay, so here Q is not the center of rotation, then QP, this line here, and Q prime P make an angle. That's the angle of rotation. If Q is the center of rotation, okay, then the image of Q is still Q. So if Q is the center of rotation, Q doesn't change. If Q is not the center of rotation, you can actually draw a ray from the original Q to the point of rotation, the new Q to the point of rotation, and that would be 40 degrees. A 40-degree counterclockwise rotation is shown as the white and the right. Rotations can be clockwise or counterclockwise. In this chapter, all rotations, unless otherwise noted, are counterclockwise. So same thing here. If we actually drew a ray from R1 to P and R to P and measured it, that would also be a 40-degree rotation. So you notice in this lesson, we're getting away from what we've done in the past, which was just 90, 180, 270-degree rotations. So we're going to learn how to draw a rotation other than just what we're used to, 90, 180, 270. So they've given us triangle ABC, and they want us to rotate it about P, 120 degrees. So we're first going to draw the segment from A to P. You can see this here. We drew this segment from A to P. We're now going to put our protractor along it and draw a ray to form 120-degree angle with PA. And we need to construct it so that, these symbols are messed up, but that P to A prime is congruent to PA. We're going to repeat that same step for C prime and B prime, and then connect the dots to draw the rotation. Rotation is about the origin. You can rotate a figure more than 180 degrees. The diagram here shows rotations of 130 degrees, 220 degrees, and 360 degrees. There are rules for rotations of 90, 180, and 270 degrees about the origin. Basically, we do this with my pre-algebra students, and what I tell them is when they give you A, B, so the digits for X and Y, every time you do one quadrant, you're going to flip-flop the values. And then I say, look at what quadrant you're in, and go ahead and put in the appropriate positive and negative sides. But basically, if you, whatever your A and B values are, so your X and Y coordinates, for a 90-degree rotation, you switch the digits, and the B is the opposite sign. The A stays the same sign, the B is the opposite side. For a rotation of 180, you keep the original digit values, but make them the opposites. And for 270 degrees, say it a different way, the value that was your Y value becomes your X value, and the opposite of your X value becomes your Y value. So you can memorize these rules. I tend to draw out a little quadrant and just think about where my points are, flip my digits, and then adjust my signs for whichever quadrant I've ended up in. So here's an example of how that all works. As I said, there's different ways you can memorize this rule because you're doing a 270-degree rotation. What I would do is I would say, okay, R is in quadrant 1, and we have here, those values are 3, 1. So if I go one quadrant, that would flip to digits of 1, 3, 3, 1, 1, 3, and because I'm going to be in quadrant 4, my X value is positive, my Y value is negative. S is in quadrant 1, 5, 1. So one 90-degree rotation would bring it to quadrant 2. This would be quadrant 3. This would be quadrant 4. Since I'm going to be in quadrant 4, my X value is positive, my Y value is negative. So if the values were digits were 5, 1, 1, 5, 5, 1, 1, 5. Same thing for T, but T is in quadrant 4. So when I rotate it 270 degrees, it's going to end up being in quadrant 3. So this was 5, 3, 3, 5, 5, 3, 3, 5, but I'm in quadrant 3, so it's negative and negative. And U, same thing as in quadrant 4. It's going to end up in quadrant 3, and my digits are both going to be negative. The other thing you could have done, a 270-degree rotation counterclockwise, remember they say in this book everything is counterclockwise, would be the same thing as a 90-degree rotation clockwise. So you could have thought of it that way. So in this guided practice problem, you're going to have to draw DEF. Then you're going to draw a rotation of 50 degrees about DEF, about P. So I will start this out to give you a little help here. It's very difficult to do on a Promethean board. Basically, I'm going to start with F. I'm going to draw a ray there. Around so that I can mark 50 degrees counterclockwise, which would be right there. Okay. I'm going to move my protractor out of the way. I'm going to use my straight line tool. I'm going to draw a ray from there to there. Now, since this is F, I need to rotate this around so that I have that correct length. Scoot it in a little bit. Now that I have that, okay, I'm going to rotate this over here, go to the pen, and actually mark it. Move that out of the way, go back to pen, and this is my new F. I need to do this with each point. And drew a ray from E to P. I'm going to go ahead and line this up. Trying to line this up exactly. There you go. Now I'm going to mark my 50 degrees. It's going to be about right there. Move my protractor out of the way. Straight line tool. I'm going to go from here to point P. I'm working on E. There we go. Tool there. I need to make this distance on my compass the same as P to E. It's going to be the same for PE prime. So now I can rotate this, bring it over here, make that arc. Move that away, put a dot there. That's my new E prime. And the same thing here to get my new point D. 50 degrees is right here. I'm going to move this out of the way. Use my straight line tool. To P. Take this. Move this out. Rotate it to this line. This is where my new D is. Then I'm going to take my straight line tool. I'm going to change the color here. Sorry, I'm going to take my straight line tool. I'm going to change the color here. And I'm going to draw E to F, F to D, D to E. So I don't know if you can see it. I'm going to highlight it. This was the original triangle. And this is the new triangle. Pull this away and kind of compare my handiwork. In this next one, I could draw it, but they actually say graph this and rotate it 90 degrees about the origin. So that's the simpler problem. We've been doing that, I believe, in the past. So since it's 90 degrees, my new J is going to have digits of 0 and 3. They're going to rotate. Since this is in quadrant 1, I'm rotating 90 degrees counterclockwise. I'm going to be in quadrant 2, where my X value is negative and my Y value is positive. But 0 is not negative or positive. So for k. It's going to rotate to 3, 4. My x value is negative because I'm in quadrant 2. And L prime, 0, 6. Obviously, x is 0. It cannot be negative. I could graph this all out, pull this away. But as you can see, I was in quadrant 1. I went to quadrant 2. Theorem 9.3 is just that rotations are an isometry. So rotation is an isometry. And whenever we're rotating, the figures are going to be congruent. Here is a standardized test practice. The quadrilateral is rotated about p. What is the value of y? The rotation is an isometry. So 2x is equal to 6. So x is equal to 3. You can now substitute that 3 in for the x here. Okay, so 5y is equal to 3x plus 1. 3 is equal to x, so 3 times 3 is 9, plus 1 is 10, divide by 2, y is equal to 2. So find the value of r in this rotation. So when we rotate this around 110 degrees, this point, we're rotating clockwise, becomes here. This point, color code these. It's going to over here. So in between the blue and the red dot there, 2s is equal to 12. Okay? So 2s is equal to 12, s is equal to 6. So color code here. I think the color coding kind of helps. You can put points, call these A, B, and C. That might work better. So I'm going to go back and do that because you won't have color coding. So this is A, this is A prime. This is B, this is B prime. So we're comparing AB to A prime, B prime. I cannot see what that original number is. That's 3R. So AB is 3R. A prime, B prime is 2s plus 3. We said that s is equal to 6. So 2 times 6 is 12, plus 3 is 15. 3r equals 15. So r equals 5. Correct answer is B. Quiz. I'm going to do this problem second because it involves drawing. It's a lot of steps. So in exercise 2 and 3, use the quadrilateral HIJK with these vertices. Okay, use the coordinate rules to name the vertices of an image HIJK for a rotation about 180 degrees. So for 180 degree rotation, here's the original H is 3, 0. So the new H is going to be the same coordinates, same digits, opposites. So opposite of 3 is -3, 0 stays 0. For I, it's 1, -4. So for the new I, it's going to be -1, +4. Remember the rule is AB becomes -A, -B. For J, 0, 4 is going to become 4, 0, and that's going to be negative. Wait, I did that wrong. I was thinking 90 for a second. So this is going to be stay 0, 4, but they're going to be opposites. And K was 1, 3. So K prime is going to be -1, -3. Pull that away. -3, 0, -1, 4, 0, 4. Oh, I copied that wrong. Whoops. Pay attention. So that would have been positive. See, it's 7 a.m. in the morning. I've been up for a while. My alarm is just now going off. This is normally when I get up. Cold this morning, couldn't sleep. Okay, so this becomes 0, 4. And K was 1, 3. It became -1, -3. So for this problem, we're asked to construct an equilateral triangle, DEF, then draw the image of triangle DEF for a 30-degree rotation about the center C of the triangle. So I went ahead and constructed this triangle and had a little bit of an issue here because they say that they want you to use the center of C and they want you to draw that. But if you remember from our earlier chapter, there's lots of centers of the circle. Do they want the circumcenter or the incenter or the centroid? So I just picked a point C, but maybe that's good that we're getting so picky here and catching the errors of the book. So the first thing we need to do is we need to construct, let's move this, a line, or at least draw this. So it's going to be a counterclockwise rotation. Remember, everything in this book is counterclockwise. So I have to kind of line this up with C and E. So we want a 30-degree rotation counterclockwise. So our new E is going to go along that line there. I'm now going to take my straight line tool and draw a ray from here to C. Now, if you remember, we need to have this over here, put that on point C, and we need this to be the same distance from C. E is going to need to be the same distance along. I was having some problems setting up this compass, but I think I got it set up now. Part of the problem might be the protractors in the way here. So now move that over here, draw the arc line, move my protractor away, and this will be my new D prime. Last piece I have to do, bring the protractor over here, spin it around, line up the, whoops, that made it larger. I didn't even know I could do that. Line up the bottom so that I'm going from C to F. Mark a 30-degree counterclockwise rotation. Why is this not drawing? Doing something wrong here. But I have a dot there, at least I can work with. Move my protractor out of the way. Okay, so I've lined the protractor up from C to F. Sorry, the compass up from C to F. I need my straight line tool to do that. Sorry about that. Line tool, draw a line. That was where I had marked the 30-degree rotation angle. Move my compass over here. Draw the line. Move my compass away, and I have found my new point, which is going to be F1. Now I'm going to take my straight line tool. You would actually just use the straight edge of a compass. I'm going to change this to, let's make this green, and I'm going to draw from E prime to D prime, D prime to F prime, and F prime back to E prime. And this space, green, in here would be my new triangle that I have rotated 30 degrees around the center C. And not to be outdone, here are the problems from the pages that you have from homework. That's a bunch of matrices. We're not doing matrices. Hope you'd enjoyed.